Big round of applause for L0ss, who we're talking about privileged access madness. Cheers.
Thanks, everyone. Good. The microphone's working. So, as you would have seen from the slide, from the program, I was supposed to have a co-speaker, Cameron Stokes, C0. Unfortunately, he's had a family emergency and cannot be here, so I'm going to have to cover his bits, and if that means that I kind of have to hand wave some of the cryptography stuff, you'll forgive me, I'm sure. So, what we're going to be talking about today is, what is a privileged access management system, what does it do, why a jerk like me might care about that and want to break into it, some specific examples of horrible/fun things that we might want to do to one, some demos, and because it's mandatory for this kind of talk, a little bit about PAM is good actually, if you actually do it good. Mandatory disclaimer, not going to cover much in the way of kind of the cloud side of things, like Microsoft Identity Manager. And also, as the slide says, vendors do like to kind of play whack-a-mole with us on this sort of thing. So if some minor detail of how cryptography works doesn't match up between the exact version of a given product that you're looking at and what we said, it's not our fault. You just might need to do a little bit of reverse engineering. So modern PAM systems are kind of an evolution of the enterprise password vault system. Most of the solutions on the market seem to have started out that way. A central application that sysadmins can store their passwords in, so they don't store them in passwords.txt on the desktop. Then at some point, I guess someone noticed that there was a bunch of increasingly baroque recommendations coming from security people about how these credentials should be rotated and managed, and you should only assign access as it's required, and you should audit access, and no sysadmins were actually doing any of that. And so the password vault vendors started bolting those features on, and then they called the resulting monster a privileged access management system. So most of the reasonably well-built PAM setups look something like this if you squint hard enough. There's a bit that the users will interact with, usually like a web interface, hopefully with some MFA on it. There's a bit that stores all the secrets, usually an off-the-shelf database server with some sort of encryption happening, hopefully. And then an assortment of other bits for doing stuff like rotating the passwords automatically, setting up short-lived sessions on managed systems, temporarily assigning privileged group membership and then taking it away again once the admins finish their business. Sometimes all of this might be in a single host, but more commonly it's kind of spread across a bunch of them. Sometimes bits of it are in the cloud, other bits are on-prem, but the kind of idea is that users needing privileged access are forced by yon well-implemented, well-configured firewall to go via that front end where their privileged access can be managed. That's kind of how it's meant to work, but unfortunately, reality is a lot less neat and tidy than that. In reality, things are rarely tucked neatly behind a firewall, and most, if not all, of the PAM component servers are domain joined. Also, Mr. Legitimate T Business is accessing the PAM system from the same laptop that he does all his web browsing and email and Office docs, and then his kid installs Fortnite cheats on and whatever. This reality sets us up, the bad guys, so that if we can compromise one of the component systems or AD itself, which is a lot easier than you might hope in most environments, we can access the system secrets in the same way that the component systems do. But wait, I hear you say, it says in that very diagram that the secrets are encrypted. And strong encryption is like the one thing this whole industry has going for it that actually works the way it's supposed to. Yes, and if you cast your mind back to Security 101, you might remember when you were taught that you should never ever store passwords in plain text, and you should never store them with a reversible encryption. You should store them hashed, and that's good advice. but unfortunately it's fundamentally incompatible with PAM systems and the way they need to work. Admins need to be able to pull out the plain text passwords for use in situations where the PAM's session broker can't set up a session for them. And the session broker needs to be able to authenticate to things on behalf of the user. So it needs to have the password too. So I'm gonna talk, or it's gonna be we, damn it, Cam. I'm going to talk a bit about how some common PAM systems store their secrets and what's involved in pulling them out. And yeah, this is an artist rendition of me hassling Cam because he does all my crypto for me. So, while THYCOTIC secret server is pretty typical of a lot of sort of PAM and password vault systems on the market, it does have one very, very weird feature, which is that it uses pig Latin to obfuscate strings in the web app code. I have no idea why. If anyone knows anyone at THYCOTIC, I'd love to know. I don't know what it achieves, but it's funny. Plus, it gives me an excuse to say ass words, so. By pretty unremarkable, I mean that like under the hood, it's pretty much this. In 90% of cases, you've got a couple of Windows servers that are domain joined. One's a web server, one's a database server. The web server knows the cryptographic secrets to get to the stuff in the database server, minus the pig Latin. This is the same for a bunch of other products. So password state, manage engines, password manager pro, a couple others that I can't think of right this second. Some of them will keep the key material in like web.config. Some of them split it up between the database and web.config. Some of them just keep it in the database next to the secrets that are being encrypted, which is very clever, but that's generally the way a lot of them work. This is the slide Cam was supposed to do with the actual cryptography, but I'll do my best. The crypto itself is mostly like pretty sane and sensible, but it does seem to be focused on a threat model where the hacker might own the database and they might not own the front end and also not own the database server or the host that the front end runs on, just the database. Each row in the database is an entry. The entry can have multiple items. The entry has its own unique key, and the items are encrypted with that key. The entry key is stored in the database, and it's encrypted with a master key that is stored in a config file on the web server. That master key is also encrypted, we say in scare quotes, but it's mostly hand-waving because it uses static hard-coded keys to do that. And according to Cam, that means it might as well not be encrypted at all. So to hack secret server, to get all the secrets out, you need db.config, or database.config it's actually called, sorry, and encryption.config. And you need connectivity to the MS SQL database. Database.config contains CREDS that will let you authenticate to the database. If it's configured to use an HSM, then you'll need to basically own the web server entirely. And if it is using DPABI, then you will also pretty much need to own the web server entirely, but that's not out of the question. There are a couple of public tools for dumping stuff out of Secret Server. Secret Server Secret Stealer is a pretty good kind of jumping off point for understanding how to do it. It's a little bit out of date in terms of versions. This is the result of the kind of whack-a-mole thing I talked about before. I understand there is a more recent Metasploit module that will do it as well. I don't know exactly how up to date that is. I haven't had to do a secret server in a little while. But thankfully it's .NET, so you can like throw libraries into or decompiler and just have a look at how stuff works. So BEYONDTRUST is another example. As I said, we aren't going to talk much about cloud stuff, and BEYONDTRUST's got a bunch of its bits in the cloud. We didn't spend a whole lot of time wailing on it. but we couldn't find a way to get into any of the cloudy bits. But unfortunately, the on-prem bits have all the same kind of unavoidable issues that everything else does. At the risk of sounding overly enthusiastic and crazy, I would say broadly speaking, you're better off with the cloud-hosted versions of most of these products, if only because the vendors are not going to let you do stuff like domain join the servers and have them sit in the same flat network as all your workstations. But yeah, unfortunately there's some functionality that requires you to have on-prem presence, and BEYONDTRUST one of them. It's got BEYONDTRUST has these things called BEYONDTRUST password safe cloud resource brokers that sit on-prem and handle these 4 jobs here. One way or another, at some point to do those jobs, the resource broker has to have plaintext CREDS to achieve these. I've only had a chance to look at resource brokers that do the middle 2, the ones in red. And I can confirm that they do have plaintext CREDS at some point, and they store them in a pretty easy to retrieve manner. So here's an example of how a cloud resource broker goes about trying to discover unmanaged passwords in computers in an environment. First, the user goes to the web interface, says, hey, go manage my stuff. The web server says, sure thing, I've got a guy for that. He's inside your network already. The cloud thing yells at the resource broker and says, go log into stuff as administrator using those passwords you already have. And the resource broker does that using the highly privileged CREDS that it stores in a SQLite database. There is some cryptography involved. So the file that these things live in is called btconfig.sqlite. The descriptions for each entry are clear text, but the secret value is encrypted. Unlike secret server, the master key only exists in LSA secret. It's called BEYONDTRUST Phoenix master key. So again, you'll need to have admin on the box to pull that out usually. But yeah, all you should really need is LSA dump and that SQLite file, and away you go. Right. Anyone who knows me well knows that CyberArk was for years my kind of personal great white whale. Every time I'd have a gig where the client used it, I'd run out of time before I got a chance to really chew on it. I'm pleased to say that since then I've had a little chance to kick it around. I'm also quite pleased to say that in terms of preventing us from yanking everything directly off disk on the encrypted password vault, it's a lot better than most. That doesn't extend to all the other components, but we'll get to those in a second, because Vault is pretty good, eh? Vault will scream at you super hard if you try to install it on a domain joined machine. It'll actually tell you that CyberArk won't provide you with any support if you do. It hardens Windows really good during the install. Turns a bunch of the usual kind of best practice stuff up to max, disables a bunch of services that aren't needed, that sort of thing. If you follow CyberArk's instructions to the letter, they'll even have you load the master key for the database off a CD-ROM or an ISO, and then eject it or unmount it after the system's booted. So that way the master key is not even on disk. So even if I somehow manage to pull a full disk backup of the Vault server and all the component servers, I still don't have all the goodies. But perhaps most impressively, the Vault service itself will actually firewall off all the other network ports other than 1851, which is the one port that Vault needs to function, and yeah, just lock them all out. So A+, no notes on that. That's pretty good. Unfortunately, in almost every environment I've seen, all of CyberArk's component servers, like the password Vault Web Access and the Privileged Session Manager and so on, they're domain joined, and at least some of them will be accessible via the usual suspects, RDP, SMB, RPC, all the typical kind of admin interfaces. So they're generally pretty pwnable once we've achieved some level of privilege escalation in AD. when these services need to interact with Vault to get their configuration settings and the juicy passwords, they do it using a CRED file. So that's a good old-fashioned INI format configuration file that's got an encrypted secret that they use to authenticate to Vault. CyberArk will encrypt the password in the CRED file using what they call verifiers. So it's basically a bunch of stuff that gets sort of tacked onto the key derivation function to make it supposed to constrain who can decrypt the value and where. Depending on how secure you want to be, you can use like one verifier or all of them or any number in between. Examples use things like the path of the exe that's being used to decrypt, or it's trying to decrypt the file, the username, the host name, IP address, serial number of the hard disk, a few other things. In terms of how well that constrains who can decrypt the thing, it really only constrains you if you're using CyberArk's own tools to do it. Obviously, if you write your own decryptor, you need to know those values. Most of them are not actually all that hard to obtain. And there is an option when you're creating the CRED file to just include all of those values in the CRED file as well, which kind of defeats the whole purpose. But yeah, if we can get these values and nerd snipe Cam into writing a decryptor for it, reversing the existing one, we can write our own. So there's 3 different versions of these CRED files. I've never seen version 1 in the wild, so we're going to pretend it doesn't exist. For version 2, there's a handful of possible verifiers, and there's already a public tool you can use to decrypt them that works pretty good. The URL's up there. For version 3, there's more possible verifier types, and the CRED file creation utility will yell at the user if they don't use enough of them. They actually have to pass an argument at creation time that's like, be horribly vulnerable or something like that. Now I've got to understand Cam's notes about how the key derivation thing works. It's pretty similar between the 2 versions. There's a few steps that involve complicated words like clone state and iterate, which, but basically version 3 uses SHA-512, version 2 uses SHA-1. If you're thinking SHA-1 is bad, Cam assures me that it doesn't matter, none of the broken bits of SHA-1 actually matter for this key derivation function. And the crypto after the key is derived is pretty much the same for both of them with a little bit of change in integrity stuff. We wrote a tool to decrypt version 3, and as far as we can tell, the only reason why version 3 was created was because someone released a decryptor for version 2. So we're not going to release ours because we don't want to play whack-a-mole with CyberArk. But Cam says that if you are reversing a version 3 CRED file and you want some help, you can contact him and he'll give you like some cheat codes and point you in the right direction. So we've got some CREDS from this. How do we use them? So in the same way as the decryption verifiers try to constrain who or what can decrypt a file by using the path of the program, doing the decrypting. The client apps that CyberArk provide for accessing Vault will tell Vault, hey, I'm the private Arc GUI client, or hey, I'm PACLI.exe. And then if the account that you're using isn't meant to be used with that client, Vault will say, authentication failure, piss off. And similarly, most of the accounts used by these component services have relatively limited privileges, so you need to be a little bit clever and make a client that lies. So it took a little bit of horsing around in mixed mode.NET assembly hell, but we eventually managed to figure out how to write our own CyberArk client that can lie to Vault about what client ID it is, authenticate to Vault, list secrets, and retrieve them in plain text. And then for bonus points in the process, we figured out that the password Vault web access server has a thing on it called a gateway account, which is CyberArk lingo for it's allowed to impersonate any other Vault user. So if you get that one account, you can log into Vault and say, by the way, I want to impersonate Jim the admin, and congratulations, you're Jim the admin. Again, we don't want to play whack-a-mole with CyberArk, so we won't release it publicly. But if you find yourself following the same path and you want some cheat codes or a pointer in the right direction, hit us up. Archon is a relatively little known, in Australia at least, vendor that has a PAM product. This one's kind of a reminder that even security products can have horrible vulnerabilities in them. You just need to look to find them, and really just look. There were also some decisions that seem to have been made early in the development process that are kind of not well thought through, but you'll see what I mean in a second. So, this product was intended to be used in a web browser with a plugin that would communicate to a local service on the user's machine, and this service then talked to the PAM server to do PAM stuff and handle installation of client apps required for privileged sessions or whatever. Unfortunately, the way it does that is by running a web server, just listening for GET requests with no authentication and not much in the way of sort of validation. So one of the instructions that it will receive is just download and run this exe I told you about. And so if you send someone who's got this installed an email and this image tag is in the email, they will download and run malware.exe without even knowing about it. And then Cam has hopefully left me with a demo video of doing just that. So we can see PAM plugins running on the right. Cam's going to put in that URL that's got our malicious image tag in it. And bang, it downloads and runs whatever we tell it to, which is just bonkers. The server also had a horrible remote command execution vulnerability. Here's a very condensed version of how we found RCE in the PAM server component. The timeline from getting a copy of the service exe to a working exploit was maybe an hour or two. So step one is open up some of the exes in DNSpy, have a look at the code, see that the server runs something called win vaulting service, which listens on TCP port 45045. See that anything that gets shouted at that port, it kind of just decrypts it using this hard-coded key that's the same across all the installs. That then gets fed to a very fancy switch statement, which decides which method it should use to handle whatever you shouted at it. Examples of methods it might use to handle that have fun names like execute PowerShell script and run custom commands using CMD, update Windows decom password, update Windows service user password, etc. And then it just runs it. You can see here there's some little bit of translation from like certain special characters to magic replacements that they have there, but it's literally just cmd.exe/c, it's just running it. And here is just running it. So there's the service it's running. User local group administrators. I know I set it up like this and I was lying. So you can see, there's the administrators are Mike and Vagrant, and that's the wrong thing. This is the right thing. It's very hard to read when it's speaking. So this is as much of the code as I had to write. All of this down here is just copy-pasted from the library that they provided called WinSub Client Vault that you can just copy. And so all I'm doing is just telling it the IP, telling it what custom command to run, and then saying create a user called BSides Perth and put them in the administrators group. Let's go. Dun, 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 dun. And it's probably off the second screen there. The command completed successfully. Let's check. Oh no, it's just trying to start out. Now we're in trouble. No, go away. Oh, thank God it's covered. You can see, Net Local Group Administrators, BSides Perth. Ta-da! All right. The cryptography, and that was also bad. My notes here literally say, Cam talk briefly about the config file where they wrote the string of ones and zeros as text into the text file. I don't know why they did that. This is Cam's notes on, I think this is a Cyberchef formula for how to just turn their like 01001110 file into a cryptographic key that you can just use to decrypt anything in the password vault. But yeah, comedy gold. So, how to do PAM right in one slide. So, you know, we keep saying it, we all keep saying it. Assume AD is already owned and never ever domain join your PAM servers. Anything that like actually goes into the database and retrieves stuff or talks to something that does and has that access, don't domain join it, because our step one is get DA. And then after that, we're like, well, I want more stuff. Where is the more stuff that DA doesn't get me? It's in the PAM system. Use separate virtual infrastructure if you're going to use virtual infrastructure. So don't, if getting DA gets me onto your virtual infrastructure, don't have your PAM stuff living on that virtual infrastructure. Whatever cryptographic options they give you to turn up, turn the knob as far to the right as you can. If they let you use DPAPI, use it. If they let you use a TPM, use it. Just turn the knob as hard as you can. Aggressively segment. Just nothing touches that vault. Nothing touches the front end except on the web port. Nothing touches any of it on SMB or RDP or any of that. And yeah, I know no one will, but if you use privileged access workstations, I'll be super impressed, and I'll give you an A on your pen test report, and yeah. And yeah, if you've been wondering, all the images in this deck are from Dutch master Hieronymus Bosch's late 1400s painting, The Garden of Earthly Delights. It's a real trip, but it had a fun depiction of PAMdemonium in it, so we thought it was appropriate. Question time? Do we have any?
Yep, 3 minutes.
3 minutes.
2.5. 2.
Sammy?
Mike, you said that never, sorry, I'm losing my voice. You said never join AD join the PAM service. But in order for PAM to work, something has to be joined, right?
I mean, the PAM servers have to, or probably have to have CREDS for AD, but the OS doesn't have to be domain joined and manageable by AD. You don't have to give the domain control of the servers.
Yeah.
But yeah, it's a matter of kind of keeping that control relationship one way. On the back.
Some of the products you work with, they will integrate, if you have it, with HSM bolts and that sort of thing. There's a lot of the research you've done, is it against just purely software, or has there been HSM involved?
I've never seen anyone actually use an HSM on one of these products, is the short answer. I recommend you do it. It's a good idea. That said, if you do it, depending on implementation details, but like, you still have that kind of fundamental problem where if I can own the, say the web server that people are using to pull passwords out, I can still somehow, I'm still going to be able to do whatever that web server can do, whether that's tell the HSM to decrypt stuff or, tell the privileged session manager to stand me up a privileged session, But HSMs are definitely going to make it harder, and that's the whole game.
So does that also mean that we're using that SAML as a way to get into the PAM?
So in terms of kind of the web side of things, anything that's going to let us, hijack a session or create a fake authentication token or whatever, that's going to be a weak point. It depends on what you're, what you're integrating it with, and whether that system that's, if it's like ADFS, well then all of a sudden, you're back to square one with exactly the same problem. That if I own AD, then I own ADFS, then I can make my own sample tokens, do whatever I want. But it's complicated. Generally, this is the other thing, is that none of this matters if we own the administrator's workstation, hijack his browser session, and then just get admin on the thing because we are being him on the thing. Then, sorry, it's 2023, I should know better. We done?
Cool. Time for one more, just one quick one.
Yes.
One question on that, instead of master key being a physical CD-ROM or whatnot, is that master key ever needed again if that PAM's included, or is it just
Yeah, so the question was about the CyberArk, the way they tell you to kind of only provide it to the system at boot or at start of the service and then like take it away. It's going to like hold it in memory where, if we got admin on the Vault machine while it's live, with enough time and stuffing around, you could get it out. And yes, the downside of that, as you notice, is that if the machine bounces, you've got to then put the CD back in the drive or mount the ISO again or whatever, and then that could have availability impacts. Yeah?
So if your CyberArk server is virtualized, does that mean you've probably got a copy of the master key sitting in an ISO on a VM file store somewhere?
Yes. Yes. And for the Snaffler fans out there, Snaffler has rules to find those files.
And on that bombshell, thanks, Ryan. Awesome help.